Every major OpenClaw release gets the headlines: 150 fixes, built-in PDF engine, breaking changes, security patches. But the releases that actually make a difference in day-to-day production use are the ones nobody writes about. The focused, targeted polish releases that quietly fix the things that were driving you crazy every single day. v2026.3.7 is that release. No breaking changes, no massive changelog, 4 precise fixes for 4 real problems, and 2 major model additions that remove the last reason to be running custom workarounds. Version 2026.3.7 shipped within the last 24 hours. It adds official ACP bindings for GPT-5.4 and Gemini 3.1 Flash-Lite, fixes the ACP binding reset bug that forced manual reconfiguration after every restart, introduces a slim Docker multi-stage build that significantly reduces image size, and extends SecretRef coverage to gateway authentication for unified credential management across everything OpenClaw touches. Let's start with the model additions because these have the broadest immediate impact. GPT-5.4 and Gemini 3.1 Flash-Lite both receive official ACP bindings in this release, meaning they are now first-class citizens in OpenClaw's agent communication protocol layer, not workarounds. The distinction matters. An unofficial model integration means you are either manually specifying the model endpoint in every workflow configuration using a community fork that may or may not stay in sync with the main branch, or routing through a compatibility shim that adds latency and introduces its own failure modes. An official ACP binding means the model is integrated at the protocol level. It appears in the model selector. It participates in ACP routing logic. It works with SecretRef for credential management, and it is tested against the full OpenClaw test suite with every release. For GPT 5.4 specifically, the ACP binding arrival is significant because GPT 5.4 introduced native function calling improvements and structured output reliability upgrades that make it materially better for tool-heavy OpenClaw workflows than its predecessors. For Gemini 3.1 Flash-Lite, the significance is different. Flash-Lite is the cost-optimized model in the Gemini 3.1 family, which means it is the right choice for high-frequency, lower-complexity steps inside Lobster pipelines, where you want to minimize per-step inference cost without sacrificing the output schema compliance that LLM task requires. Now, both are available natively, without any configuration gymnastics. The ACP binding reset bug has been in OpenClaw since the ACP layer was introduced, and it is the kind of bug that does not sound catastrophic until you are actually running OpenClaw in a production environment, and then it is absolutely catastrophic. Here is what was happening. You configure your ACP bindings, your custom model routing rules, your specialized agent configurations, your per-workflow model assignments. You save the configuration. OpenClaw runs correctly. You restart OpenClaw, which happens routinely for updates, system reboots, server maintenance cycles, or Docker container restarts, and every ACP binding is gone. Reset to defaults. Your custom routing is gone. Your specialized configurations are gone. You are back to square one. For a developer running OpenClaw casually on a local machine, this is annoying. For a business running OpenClaw on a server to manage automated workflows, this is a production incident every single time the server restarts. The binding reset means every automated workflow that depended on a custom ACP binding is now routing to the wrong model, potentially producing incorrect outputs, until someone manually reconfigures all the bindings again. The fix in v2026.3.7 makes bindings persistent across restarts, exactly as you would expect them to be. Bindings are now written to a persistent configuration store rather than held in memory, meaning a restart reads the stored binding configuration and resumes from the correct state. This is the behavior that should have been there from day one, and the fact that it is now correct makes v2026.3.7 a required update for anyone running OpenClaw in any environment that restarts. The OpenClaw Docker image size problem has been a persistent source of friction for anyone deploying OpenClaw in containerized environments. The base image has historically been large enough to cause meaningful problems. slow pull times in CI/CD pipelines, image size quota issues in constrained hosting environments, and unnecessary bandwidth consumption every time a new version ships. The root cause is structural. The original OpenClaw Docker build included the full development dependency tree, all the packages needed to build OpenClaw from source in the final runtime image. This is a common Docker anti-pattern that inflates image size significantly. You are shipping the entire kitchen to every customer when all they need is the finished meal. The multi-stage build introduced in v2026.3.7 separates the build environment from the runtime environment. Stage 1. Install all dependencies, compile everything, run the build. Stage 2. Start from a clean base image, copy only the compiled artifacts from Stage 1 and ship that. The development dependencies, the build toolchain, the intermediate compilation artifacts, none of it ends up in the final image. The result is a significantly smaller runtime image that contains exactly and only what OpenClaw needs to run. For containerized deployments in particular, Kubernetes clusters, Docker Compose stacks, managed container services, this is a meaningful quality of life improvement that compounds over time. Every update pool is faster. Every container start is faster. Storage consumption across multiple running instances is lower. None of these are dramatic individual improvements, but they accumulate into a meaningfully better operational experience. SecretRef is OpenClaw's credential management system, the layer that handles storing, retrieving, and rotating credentials for all the external services OpenClaw connects to. In previous versions, SecretRef covered the 64 supported service integrations, Gmail, Stripe, GitHub, Telegram, and so on, but gateway authentication was handled separately through manual configuration. The problem with that split was both security and operational. Security. Having two different credential management systems in the same application means two different attack surfaces, two different places where a misconfiguration can expose credentials, and two different places that need to be audited. Operational. If you are rotating credentials, which you should be doing regularly, you now have to do it in two places, with two different interfaces and two different verification processes. The v2026.3.7 extension brings gateway authentication into the SecretRef system. Gateway credentials are now stored, managed, rotated, and audited through the same interface as every other credential OpenClaw handles. One system, one audit surface, one rotation workflow. For security-conscious deployments, and given everything that has happened with OpenClaw CVEs over the past few weeks, every deployment should be security-conscious. This unification is a meaningful step toward a cleaner security posture. Taken individually, none of these four changes is a landmark feature. Taken together, they tell a clear story about where OpenClaw's development focus has shifted in March 2026. The early releases, v2026.1.x through v2026.2.x, were capability releases. New features, new integrations, new models, new tools. The changelog was always massive, because the project was still establishing its feature surface. The security crisis in late February forced a different kind of focus: hardening, patching, CVE remediation. v2026.2.23 and v2026.2.25 were emergency security releases. v2026.3.7 is neither a capability release nor a security emergency. It is a polish release, the kind of release that happens when a project starts taking its production user base seriously. Persistent ACP bindings, smaller Docker images, unified credential management. These are not features that make demo videos exciting. They are the features that make it possible to run OpenClaw reliably in environments where reliability actually matters. That shift in focus is arguably the most important signal in this release, more important than any individual change it contains. No breaking changes, 4 targeted fixes, 2 major model additions, and a clear signal that OpenClaw's development focus has matured from capability expansion to production reliability. Update immediately. Verify your ACP bindings survive a restart. Check your Docker image pull times. And subscribe for full, ongoing coverage of every OpenClaw release, because at the pace this project is moving, there will be another one before the week is out.